Hey, there's a recording for 6 already in chapter 7. Guys, you didn't miss anything. for those watching the video, we had a good time.
He said he was giving us all Lamborghinis.
We went over the reciprocal identities. They're here. These are the Pythagorean. You only really need to remember this first one, and you can get the other two by dividing by sine squared or cosine squared, and you'll get these two. Okay, now we're on the addition and subtraction identities. So we have sine x plus minus y equals what?
Sine x.
Sine x?
Wait, sine x, cosine x. Sine y, cos y.
You're thinking about cosine.
Sine x, sine y.
Sine x, sine y, cos x, cos y.
Okay. Sine x, cosine y.
Wait, that's what I said. Oh.
Plus minus cosine x, sine y.
It's plus minus, not minus.
It's plus minus. It's the other one. You guys are thinking about the other one. So cosine plus x plus minus y, that's the one you guys all shouted out. So that is what? Cosine x, cosine y, and then it's minus plus sine x, sine y. Okay? The double angle identities.
But what about tan?
Oh, you don't even know tan.
Oh, thank God. Wait, what was the
I remember like 1 over like.
Is that what it's
1 over 1 minus
Don't waste your brain power.
Tan. Yeah, don't waste it, guys. Just save it. Don't even think about it. All right. Double.
Wait, what about like adding and subtracting angles? When did we do that?
We did that. That is what this is. I think here's what you're thinking of. Like if you wanted to find like sine 75 degrees, you add sine 30 and sine 45, and you plug them up. You plug those values in here.
Oh,
Remember that? Yeah. Double angle identities. Sine 2 theta. There's only one option. Do you remember it? Sine 2 theta. No. 2 sine theta, cosine theta.
Oh yeah.
Okay. And then cosine 2 theta has the 3 options. Remember this?
Sine
squared theta plus 1 or something.
You're so close.
Cosine 2 sine squared theta.
There's nothing a cosine squared in it.
Oh, sine squared plus cosine squared.
Minus sine squared. And then using again, you only really know this one, and then we can use the what? Anyone?
The other stuff.
Pythagorean identity. And that would get us the two other forms, which are 2 cosine squared theta minus 1 and 1 minus 2 sine squared theta. Okay?
Wait, that's all for cosine.
Yeah. Okay, this is the last one, even and odd. Okay, just which ones are even and which ones are odd, guys? Which of the functions are even and which of the functions are odd?
Oh, if it's asymmetrical about the y-axis.
So if we go back and look at our little...
If the degree is positive,
Which ones are odd and which ones are even?
No, this is.
Cosine's even. And secant's even. The rest are... Yeah. Hello? Okay, so that means when we do our even odd identities, what do we say? So the odd ones, let's separate them out. The odd would be sine.
yeah, Alex is doing about
And then the even one, there's only one even one, is cos.
Wait, when did we do this? I remember.
We did this.
We did. I remember this.
Okay, well, this is just application of odd and even functions, saying that sine of negative theta is the same as negative sine theta, and cosine of negative theta is the same as cosine. It's just saying that they're symmetrical about the y-axis or they're symmetrical about the origin. That's it.
Wasn't there a question on one of the tests we had that was like this, but it was like sine negative theta is equal to sine theta?
Nobody remembers that part.
Sometime I don't.
Where the memory are you finding?
Okay, we're on the last page.
Okay.
We'll circle back to that. All right, solving trig identities. What do we remember about this, guys?
Oh, you have to like make it, you can solve one side first.
Oh yeah.
Yes, like move one side at a time.
So you can choose one side,
Wait,
or
can I share what Mr. Lee said?
tell me.
He said, "Oh, I can't remember. Keep in form of sine over and sine and cos. Don't use tan. Use the identities at the end and don't move it over to different sides."
Well, you kind of need to use tan.
Yeah, I know, but only do it at the end. His tan just like more complicated. Yeah. Mr. Lee said
I mean, these are the main hints that come to mind. So like, choose one side. You can do a bit of both, but do one at a time. You're not moving stuff to either side. And changing everything to sine and cosine is helpful. Okay? Let's do some examples. Yeah, why don't you try them by yourself? What? Yeah, take a stab at these. I'm going to pause the video.
1 over.
All right. So, see, we got some identities. You're proving that these two are the same. We can do a little bit of both. I think something that stands out to me here is this 1 over secant is the same as cosine. So now, I know this is cosine. This whole thing needs to be equal cosine. So, okay, let's do it. Let's convert things to be sine and cosine. Well, what's tan times sine? So this is really, tan is sine over cosine times sine. And this is 1 over cosine, right? So really we have 1 minus sine squared over cosine. Let me add those x's in there. Right? And so what's 1 minus sine squared though? 1 minus sine squared is? Cosine squared over cosine is cosine. So we're good. Cosine x equals cosine x. We're done. Good? On the right side, it was kind of a similar problem. You have tan over cotan. That's sine over cosine over sine, which is the same as what? Sine. Hello? Sine squared over cosine squared.
1, 0.
And on the left side, you've got 1 over cosine, which is 1 over cosine squared. So then we have 1 minus sine squared over cosine squared. And I know that's cosine squared. So that's it. That's 1. Okay? So, you know, I'm not here to throw you massive curveballs in the final. There's a lot of content. Right? There's a lot of content. So let's keep things straightforward.
Thank you.
We have 2 more classes. Let me stop the video.